Hello, so this is the video that will explain how to do the practice exam I gave out on Wednesday. So what I'm going to do is I'm going to share the screen. I'm going to have the question and an Excel sheet. I'm going to do everything in the Excel sheet. That's just a little bit easier. You can do whatever you feel is better. And then I'll see you all later today. So I'm going to um, pull up the exam thing. So let me share my screen. Entire screen. Yes. So I'm going to share that. All right. So you should be seeing the Excel sheet and the question. So I'm going to do the questions in turn. Firstly, I'm going to call this question one, rename this Q1. So this is, you want to understand if Cal Poly students spend $140 a year, the average across the United States. You run a survey, 26 students. Survey mean is 120, standard deviation of 25. What's your best guess for how much Cal Poly students spend on books a year? What's the 95% confidence interval? Can you reject the null hypothesis? So the null hypothesis, HO, is 140, right? My hypothesis is that they're exactly the same as 140. The mean of my survey is 120. The number of observations is 26. And the standard deviation is 25. So there's a couple of things I've got to work out, right? This is asking me to create a confidence interval. So I'm going to have to work out T. I'm going to have to work out standard error. Yeah. So T is simply degrees of freedom minus one using that T table. So let's pull up the T table. So I've got 26, so that's 25, 2.06. All right. So T is 2.06. My standard error, if I go to the equation sheet, remember that's equal to the standard deviation divided by the square root of n, 4.902. If you round it to 4.9, if you're doing it by hand, that's perfectly fine. So now I've got to find the lower and upper confidence intervals. So the lower confidence interval is simply equal to the mean minus bracket T times standard error. So the lowest I would guess it to be is 109.9. So say 110. The upper confidence interval is equal to the mean plus bracket T times standard error. So 131. So I think 95% of the time, Cal Poly students spend between 110 and $130. That is lower than its statistic. The null hypothesis is not there. So I can reject the null. All right, there it is. Oh, and I'm going to say my best guess is 140. Oh, sorry. I should do this in dollars. $140. Right. That's my best guess. Right. That's the single point. And then I'm pretty confident that they're different. It's easy enough. So I'm going to do question two. So Q2. This is, the average rate. So this is I've got to use the normal distribution, right? I've got someone, I want to know how different they are. So the average height in the US is 64.5 inches for women with a standard deviation of 3 inches. Simone Biles is how tall? She has a Z of negative 2.3. So what I'm going to do is I'm going to go negative 2.3 Zs and work that out. So yeah. No, I just want negative 2.3. You don't need to tell me it's an equation. All right, so I'm going to go to tables. I'm going to look up 2.3. So that's 0.0107. What is her height? So she's smaller than 1.07% of the population, right? Or she's taller than one. So she's taller than 1.7% of the female population. Simone Biles' height is going to be 64.5 inches plus bracket 3 times negative 2.3. Oh, should have put an equal in there, shouldn't I? Of course. And that means that she's 57.6 inches tall, which seems reasonable, right? About 2 standard deviations. So it's about 7 inches shorter, which is what you would think. Okay, it's fairly easy. All right. All right. So question 3. You work for the political science department, you want to collect data, grades. This is the student data report. So it's just on Cal Poly data. So this is the data. John Smith, GPA, Lucy Jones, Mohammed Stevens, Maria Gonzalez. I've got all this data from them. Now, this is not public data, so I'm going to create a unique identifier. What else is interesting here? Well, major is all political science, right? So that's not a variable, so I don't need to include that. I do need to include whether someone is a California resident. I think Maria Gonzalez, this is an obvious mistake, right? It just says YE, probably meaning yes. So I'm just going to consider that yes, and then I'm just going to type all of this data in. I'm not actually going to type this data in because that's going to take me some time. But fortunately, I've done it before. I will, you know, I create code book for um, each observation, and now I must summarize it. So I've unique identifier. I've not included political science, so I'm going to highlight all of this. Now this is always good when you. So I'm going to go to data. I'm going to make this big because I can see it. Move there. Data analysis, and I'm going to use descriptive statistics, and I'm not going to highlight ID number. I'm not going to summarize that. Let me include everything, label, summary statistics, click OK. So these are my summary statistics. So if I look at this here with the GPA, the mean or median is good. So I might report the mean or the median, but they're so close, it doesn't really matter. For year, I would report the median because it's a category. And for California residents, I could report the median, but actually here I might report the mean. This is a bit odd, right? Because it's a binary variable. So I would actually say about 75% are California residents, but I would also accept the median there. But I think the mean is actually better because it tells us which percent are which. So this is rename Q3 stats. Yeah. And this is rename Q3 data. All right, is that all I needed to do on that? Let me click on exam. As part, you get student data, create a data set, report measure of central tendency. Yeah, that seems good. All right. So then finally, Q4. Oh, so let's see what that is. Oh, I think that's the Excel sheet that I'm in. So using Excel, create 2 new variables, number of guns per people in the state and number of degrees per 100 people, report measure central tendency for each new variable, create histogram of gun ownership, make pivot table organized by region. All right, that all seems good. So let's do this. So I've got this data. The first thing I'm going to do, well, I'm not going to summarize it yet because this might be a bit odd. So I'm going to do guns, 100. And I'm going to do grads per 100. So guns per 100 is simply going to be equal to guns divided by population times 100. Yeah, it's about 3.4. Now, I'm going to copy this down. Could I copy this across? The problem if I copy this across is it moves graduates, but it doesn't move guns, right? It doesn't move population. So I don't want to do that. What I'm going to do instead, in front of this C, I'm going to put the dollar sign. And the dollar sign means that when I go across, you'll notice that I stay in C2. Like the dollar means stay in a column or stay in a row. All right. So I've created variables for both of these. I'm just going to click. So these are my variables. I'm going to format the cells. These are ugly. Number two. Yeah. I'm going to create code book. Guns per 100 population. What's actually the code for this? University graduates of the state. So all right. So I've created both of those variables, very easy. Now I'm going to go to the data analysis toolpack, data analysis, descriptive statistics. It, of course, things I was doing in the old place, so I'm going to expand that. Oh, look, that one looks odd. I'll get to that. Okay, so here we see region. I would report the modal region, right? So population, I'd support the median. Guns, I'd probably do median. University degrees, I'd do median. Now, here we see there's an outlier in guns per 100 and mean or median for grads. So let's look at the minimums and maximums, right? These seem reasonable. 23, when we look at the data, we'll see that there's obviously something wrong with Wyoming, right? There's probably, it's probably that there's an extra zero there. It's probably something like that, 13405 instead of 134. So what I would normally do is check this. I'm going to highlight it, say odd. Now, you have two decisions. They're perfect, both perfectly reasonable. You can decide that to delete this data and think it's incorrect. I think it's probably incorrect, and that's probably what I'm going to do because I'm going to make a graph, and the graph's going to look really, really weird if I don't do that. Or you can keep it in, but you should say, I've looked and this looks really, really strange. This looks like really odd data. I'm going to delete that because I think it's wrong, but it's up to you. So now I'm going to run the descriptive statistics again. And I'm going to run descriptive statistics. Oh, I don't need to do that, do I? Data analysis, it's just going to do exactly the same thing. Okay, so let's look at this. So what we see is region, mode is still correct. Population, median, guns. You see how guns now seem a lot more similar, but still keeping that one. Right, you see how these two are now very similar, right? I think I would probably report the median for all of them. And region would be, so let's have a look, 3, so that's the south. Yeah, but that's how I'd report that. So I've got to do that. Now I've got to make I think I've got to make a histogram to show gun ownership. You see, if I kept that 23 in, that histogram would look really bad. So let's see what we go from gun ownership. So really it goes from about half to about 5.5. So let me do this really fast. Make two graphs, see which one works best. All right. So data analysis, go to histogram, input range, guns per 100 people. Yeah, excluding Wyoming, of course. Chart output. Where did I? Oh, did I not put in? Yeah, I didn't put in. So it did it itself. There you go. Bins. Click OK. That doesn't look too bad. Let me just do this. Make sure I get. Let's do another one. Histogram. I'll delete this because that more shouldn't be there. Well, I think both of these graphs are pretty much the same. So I'm going to stick with this one. Going to get rid of that. Less than one. Yeah. I would normally put this into a Word document, but I'm not going to. I'm just going to do this. So this is going to be figure one. Yeah. Number of guns in state per 100 people. That's perfectly fine. And then I've got to make, I think, a pivot table organized by region showing the number of guns owned. All right. Just number of guns owned by region. So there's number of guns. Yeah. Total number of guns. Okay. So let's go to data. Going to click in here, insert table, pivot table, pulling everything up, region. Oh, yeah, that's not going to look very good, is it? So what I'm going to do first. So let me sort these three. Sort by region. So this is East, Midwest, South, and then West. Now I'm going to click here. Let's see, this is pivot table. I'm going to delete this. Okay. Region 2. You see, if I'd just done numbers, that would have been difficult. And then guns. So I do want the sum of guns. So I wanted something else. Remember, I go to field values and change all that, but I'm not going to do that. That's the total guns. And that's it. The sum of guns. So you can see the South has more guns than the West, then the Midwest, and the Northeast. So this is rename pivot table. This is the histogram to use. some class. All right. And then that's it. That's what I would submit. Okay. So it's very easy. Didn't take me very long. Shouldn't take you very long, so you should be good. Okay. I'm having extra office hours this afternoon. I think let's say I'll be on Zoom between 4 and 6, right, this evening on Sunday. All right. So I'll email this, post it to all of you, and then send you another email. So if I don't see you between 4 and 6 today, I will see you at either 4 o'clock tomorrow or 6 o'clock tomorrow. All right. Bye bye.